Good morning children, Sairam. Children, in the previous presentation we have learned about the two colligative properties. The first one was relative lowering in vapor pressure and the second one was elevation and boiling point. Now today in this presentation we'll be learning about the third colligative property, that is the depression in freezing point. But before that, we'll first solve the two numericals that I've given you in the previous presentation. The first numerical that I've given to you was this. Now children, according to this question, the boiling point of water at the given pressure is 99.63. This 99.63 is the boiling point for the pure water, that is T0B. Now it is asked that how much sugar is to be added. How much sugar is to be added? That means what is asked in the question? The value of WB is asked in the question. Now it is given that how much sugar is to be added to 500 gram of water. That means the weight of solvent WA is given to you. And it has been told that the solution should boil at 100 degrees Celsius. That means the value of your TB, it is also given to you and it is 100 degrees Celsius. Now applying the formula that we have derived the last time, that was delta TB is equal to TB minus T0B. TB is 100 degrees Celsius, T0B is 99.63. Subtracting the two, we get 0.37 degrees. Now, the formula for molar mass we are applying, and in that formula, the molar mass we are already knowing as the name of the solute is given to you, that is sugar. So, for sugar, the molecular formula is C12H22O11. On the basis of that, you can calculate the molar mass, put the value of molar mass in MB. KB is also given to you, that is 0.52 multiplied by 1000. It should be 1000 into WB. WB we have to calculate. Weight of solvent WA is already given to you, that is 500. Delta TB we have calculated up, that is 0.37. Now putting all these values, we get the answer of WB as 121.7 grams. Now the first question is done. We'll start with the next question. The next question that I've given you in the previous presentation, it was this question: the aqueous solution of 2% non-volatile solute exerts a pressure of 1.004 bar at the normal boiling point of the solvent. Calculate the molar mass of the solute. Now children, here I've already told you that the meaning of 2% is that 2 gram of the non-volatile solute is added to 98 gram of the solvent. So WA and WB comes out from this 2%. Now see how to solve the question. The vapor pressure of pure water at 1 atm is, you all know, 1.013 bar, and for solution it is given as 1.004 bar. So subtracting the two, we get the lowering in boiling point divided by 1.013, that is of the pure solvent, and putting these values, WB is given to you, MB we have to calculate, MA is 18 and WA is 98. 2 gram of solute and 98 gram of water. So the answer comes out to be 41.35 gram per mole. Now children, today we have to start with the depression in freezing point, that is the third colligative property. Children, you must have heard that in cold countries where a lot of snowfall takes place, there the salt is being sprayed on the snow so that it can melt easily. Now, do you know the reason behind that? I'll tell you the reason. Children, if a non-volatile solute, that means if a solute which cannot evaporate is added to a solvent, then it lowers the vapor pressure, which depresses the freezing point. And Why NaCl is sprayed on snow? So that the freezing point can lower, and at that temperature also, below 0 degree Celsius also, the this snow can melt. Now what is freezing point? How is it related to the vapor pressure? We'll learn today. See, freezing point of a substance, or you can say the melting point also, of a substance is that temperature at which the liquid and the freezed state have the same vapor pressure. Now with the help of this graph, you will get to know how this happened. By on adding a non-volatile solute, the freezing point of solution decreases. Now here you all can see on the x-axis is the temperature, on the y-axis is the vapor pressure. Now this line corresponds to the freezed state, and this line corresponds to the pure solvent. Now pure solvent, the vapor pressure touches the freezed state here. Here it touches the freezed state. That means this is the freezing point of the pure solvent, which we have denoted by T naught F. And if a non-volatile solute is added to it, then the vapor pressure becomes less. So it touches the freezed state here. So this will give you the value of TF. TF is the freezing point of the solution. Now this difference in the freezing point of pure solvent and the solution will give you the value of delta TF, that is the depression in freezing point. This difference is called the depression in freezing point. It is delta TF is equals to T naught F minus TF. Children, you have to remember, as the depression is taking place, that means the T naught F will always be greater than TF. So you have to subtract in this way. Whereas in the previous case, when we were doing the elevation in boiling point, it was TB minus T naught B. Here it is T naught F minus TF. Now I think you all must have got to know what is depression in freezing point. Depression in freezing point is when a non-volatile solute is added to a pure solvent, the freezing point decreases. Now children, one more thing is there that you should know. In the cold areas where the temperature is very low, there in car radiators, water is present, you all know. Water freezes. So in order to make it not to freeze, some quantity of ethylene glycol, which is a non-volatile solute, it is in the form of a liquid. Ethylene glycol, you all know the formula, it is CH2OH, a single bond CH2OH. Now this ethylene glycol is added to water in the car radiators in order to prevent it from freezing. Many a times this 1 mark question comes in the board exam. Why is ethylene glycol added to water in the cold areas for car radiators? You have to say in order to depress the freezing point. And the same question that I have told you in the beginning can also come. Why NaCl, salt, is sprayed on the snow? In order to depress its freezing point so that it may melt easily. Now, as depression in freezing point is a colligative property, so it is directly proportional to the molality of the solution. Molality is small m. Now removing the sign of proportionality, a constant comes, that is Kf. Kf is the molar freezing point depression constant, also known as cryoscopic constant. Now in the board exam, once this question came, how will you define Kf? How will you define? See, Kf is the difference in freezing point of the solution when the molality of the solution is 1, or you can say delta Tf will be equal to m, will be equal to Kf if molality is 1. Clear? So how will you define this cryoscopic constant? It is the depression and freezing point of a solution whose molality is 1 molar. Now children, with the help of the colligative property, what we do? We always calculate the molar mass of the non-volatile solute using the colligative property. Now, today also we'll be calculating the molar mass of the solute. You all know delta TF is equals to KF into M. Extending M, we get WB upon MB into WA multiplied by 1000. Now, with this, you can take MB to the left hand side, take delta TF to the right hand side, and you get the formula for calculating the molar mass of the non-volatile solute. Now children, on the basis of this formula, any numerical can come to you. I am giving you one question as a home assignment. I hope you will be able to solve this. It is a simple question. Just put the values in the formula. You will get to know the answer for this. Okay, now your third colligative property is also over. That is depression and freezing point. Now today only we will start with the fourth colligative property. I'll give you the introduction of the fourth colligative property. So 3 colligative properties we have already done. What were those? The first one was a relative lowering in vapor pressure. The second one was elevation in boiling point. The third one that we have done today is the depression in freezing point. And the fourth one that we are starting now is the osmotic pressure. Now children, do you know the meaning of osmosis? What is osmosis? Yes, it is the movement of solvent particles from the region of its own higher concentration to the region of its lower concentration through a semi-permeable membrane. Is that clear? Now, in other words, you can also define osmosis as the movement of solvent from solvent side to the solution side. Children, diffusion also you all must have heard. Diffusion is different from osmosis. Osmosis includes a semi-permeable membrane, and in osmosis only the solvent particles move, whereas in diffusion no semi-permeable membrane is there. Now, osmosis and diffusion, in both of them you can say from whatever moves, it moves from its higher concentration to its lower concentration. Now, osmotic pressure, that is the important thing that we have to study today, is the fourth colligative property. Now, what is the meaning of osmotic pressure? See, children, you all must have seen resins. Resins, when put in water, the dried up grapes, when they are put in water, what happens? Yes, they swell up. Why do they swell up? Because they absorb water. Now just consider this, that the outer membrane of the resin is a semi-permeable membrane. What are semi-permeable membranes? They are those membranes which allow only the solvent to pass through but do not allow the solute particles to pass through them. Now, resins, when kept in water, they swell up due to osmosis. Osmosis means the water which is present in the bowl, it is present more outside the resin compared to the quantity inside the resin. So, water will move from outside to inside of the resin. This is called the osmosis. Now, osmotic pressure I have to explain. Just see this figure. In this figure, we are having a container. This big container we have, just a minute. This big container we are having, this container has two sides separated through a semi-permeable membrane. This is the semi-permeable membrane. This side is the solvent, this side is the solution. Solution means solute plus solvent. Both the things are present here. Now children, suppose there is these two frictionless pistons are fitted here. these are the two frictionless pistons. We have fitted here, this and this. Now, when the concentration of the solution is less, then what will happen? The solvent will move through the semi-permeable membrane towards the solution side. Now, this will pull the piston upwards because the quantity is increasing. The frictionless pistons are put. Now, what happens? If suppose I'll apply some pressure here. If suppose I'll apply some pressure here, what will happen? The solvent will stop coming from here to here. Why? Because I'm applying the pressure here on the solvent, due to which more solvent will not be able to come to this side. Now, this pressure which is applied on the solution side to just stop the process of osmosis is called the osmotic pressure, denoted by pi. So, the pressure which must be applied on the solution side in order to stop the process of osmosis is called osmotic pressure and is denoted by pi. Now, children, can you tell me what will happen if I'll apply pressure more than pi? That means more than the osmotic pressure. Then what will happen? Yes, reverse osmosis will start taking place. If pressure more than pi is, if pressure more than osmotic pressure is applied on the solution side, then the solvent from the solution side will start moving to the pure solvent side. That is called the reverse osmosis. Reverse osmosis means the RO technology that we are using at home for water purification. In that, RO technology is used. That is, reverse osmosis technology is used. That means this is pure solvent, that is water. It is impurity containing solution. Pressure more than osmotic pressure is applied and pure water moves to this side, which is used for drinking purpose. Now children, one more use of reverse osmosis is the desalination of seawater. From seawater, the salt is separated using this reverse osmosis phenomena. Now, next thing that we have to study is how we can say that this osmotic pressure is a colligative property. Children, Went Hoff, he studied the osmotic pressure in detail and he got to know that the osmotic pressure of a solution is equal to CRT, where C is the molar concentration, molarity. So, you can also say pi is equal to capital M into R into T, as R and T, you all know, are the gas constant and temperature. They both are constant. That means you can say this is proportional, pi is proportional to C. As it is proportional to concentration, that means it is a colligative property. Now, what we do with the help of colligative properties? We determine the molar mass of the non-volatile solute. How to determine? Extending C, that is molarity, we get N upon V into R into T. Now, extending N is the number of moles, will give WB upon MB into volume of solution in liters. It should be in liters, you have to remember. Now, what we have to calculate? MB. Take MB to the left hand side. It becomes WB into R into T upon volume of solution into pi, the osmotic pressure. Using this formula, you can calculate your molar mass of the non-volatile solute whose name you are not knowing. Now children, we have now completed with the colligative properties. All the 4 colligative properties we have done. Now, in your first chapter, that is solution chapter, only one topic is left, that is the Went Hoff factor. Children, I want you all to download the PDF for the NCERT book and do solve the exercise questions. These exercise questions are like those questions only that we are discussing here. Do solve the exercise question. They are simple, only putting values type question in the formula. Those which are quite, you can say, difficult, that will be solving here. I request you all to kindly download the PDF for the NCERT textbook along with the exercise questions. This is the homework for you today. Now children, Sairam, thank you. We'll proceed with the next topic in the next presentation. Thank you so much.